Ready?
Mm-hmm.
We're here today to help out my friend Judah. He has a go-kart that he has loved for a long time, but the 20th century battery technology he's been using has been letting him down, hasn't it?
Yep.
In fact, the last set of batteries didn't even last you a year.
Nope.
But we're going to fix that today. I've worked with LiFePO4 batteries on lots of projects in the past, and I've been very happy with their performance. So I reached out to them to see if they were interested in sending me their new golf cart batteries for Judah's go-kart. They said yes. So, Judah, are you ready for an upgrade?
Yes.
All right. Welcome back to Projects with Everyday Dave. Let's put some golf cart power in Judah's go-kart. Here's all our parts. Are you ready to improve the performance of your go-kart?
Yes.
All right. Now I understand you're excited to be on YouTube. You ready to be YouTube famous?
Sure.
You think all your friends are going to watch this?
Maybe.
Think they'll be impressed?
Mm-hmm.
How many views do you think we'll get?
10,000 likes.
10,000 likes? Okay, well, Judah wants 10,000 likes, so you better ask him for it. You say, hey, be sure and give me a thumbs up so I can get 10,000 likes. Ask him.
Be sure to give me a thumbs up so I can get 10,000 likes.
I bet that'll do it. We'll see. All right, Judah, here is all the parts that we're going to work with today. This is the battery that LiFePO4 sent us, and this is a golf cart battery, and it can manage 48 volts. Now, your go-kart used 48 volts before, but it did that with these small AGM 12-volt batteries all put together in series. And it's very heavy. I'm going to flip this up. Have you opened this before? Okay, well this is what was running your go-kart, and it's got these chintzy little wires holding it together, but these little AGM 12-volt lead-acid batteries, they're from the 20th century, and they just don't perform as well as the new technology that we have today. So we're going to switch to lithium iron phosphate, and I'll explain the difference between those in a minute. So we have a battery, then we have a breaker. Now this particular battery, it can put out 30 amps all by itself. And your go-kart doesn't need 30 amps. And if we were going to run 30 amps, we'd have to use really big wires. So in order to manage the electricity without any kind of danger of the wires shorting or something like that, we're going to add this circuit breaker. I made up this particular breaker for you so that you could manage that power. And all I did, I bought this breaker in a box off of Amazon. They're not that expensive. And then all I did is I wired this 12 gauge silicone wire right into one side of the breaker with an Anderson connector on the other. I put a little bit of hot melt glue in the back there so that the wires don't get fatigued on you. And then on the other side, I ran some 12 gauge wire with some heat shrink lugs on the end that we can bolt directly to the battery, or we can connect through the shunt if we're trying to measure it that way. This circuit breaker is good for 20 amps, and we'll be able to turn the go-kart on and off with this breaker. If there's ever a problem, you can switch it off and that'll cut power. And if something ever draws too much power, this will trip and shut everything down for you. Okay, now LiFePO4 has all kinds of materials for upgrading a golf cart, and some of those I've got laid out here. This is a shunt, and it uses these little bars and measures the difference in voltage across this while you're running, and it will tell you exactly how much power you're consuming, and it would tell you how much battery power is left, and it would tell you how much you're using at any given moment. And it has a little screen so you can see all that information. This is a bus bar. If we were putting this in a golf cart, we might use several of these batteries so that we could go maybe 50, 60, 70 miles on one charge. And in that case, we would use a bus bar, and you could connect multiple batteries into one connection point. Now, one of the things you're going to need to be able to do is charge your battery. So LiFePO4 has sent us this 8 amp 48 volt charger, and this will allow you to plug it into the wall. It has an Anderson connector on it, and all the wiring I've made up for you uses these Anderson connectors. If we wanted to charge this with solar, we have this 60 amp solar charge controller. Now the really cool thing about this particular charger is it can charge 12 volt batteries, 24 volt batteries, 36 volt batteries, or 48 volt batteries. So you could have one of these things. You could use it to charge your golf cart, or in your case, a go-kart at 48 volts. Then your dad could switch it over to 12 volts and charge up the RV, which is a 12 volt system. So it's really flexible. Now today, you are going to be driving your go-kart on sun power. Have you ever driven on sun power?
Nope.
Well, we charge this battery using a solar charge controller, and all of your driving will be with sun power. How cool is that?
Really cool.
It is really cool, isn't it? And in fact, we'll look at the solar panels that I use to charge it here in a minute, but they're very similar to these. These are bifacial. They can pick up sun from both sides.
Wow.
Yeah. All right, so I want to explain a little bit about the difference in battery technology to you. This chart shows lithium iron phosphate, which is what this battery is, and lead acid, which is what this. And in fact, this is one of the best lead acid batteries you can get. It's AGM. And AGM has glass mats in it that improve that old technology just a little bit. But even that doesn't compare to this. This is the same technology that is used in electric cars, and it's the exact same technology that I use to power my house. These batteries can power the whole house.
Wow.
Yeah. So what makes these different? Well, this battery can handle 6,000 cycles. Now, you said before that these batteries didn't even last you a year. Well, that's because they can only handle about 300 cycles before they die. 6,000 cycles, 300 cycles. So these will last much, much longer. Now, they have about the same capacity. They're both 30 amp hour batteries. However, these kind of batteries, you can only use about 50% of their charge or you damage them. Now, one of the reasons you probably killed these really quickly is you rode the go-kart until it just totally ran out of power and then you charged it, right? Mm-hmm. But actually, they're only capable of about 50% of their use if you want them to last a long time. This one, you can use 80% of its life or 80% of its capacity, and it will still go for 6,000 cycles. The technology within this battery will automatically turn it off before it gets too low to be damaged. These batteries don't have that kind of technology, so they get destroyed really quickly. Another nice thing, these you have to plug in all night to charge. But this one, with this charger, will charge in about 3 hours. In fact, in probably 2 hours, you'll have enough to run it for quite a while. You could charge it in 1 hour if you had a big enough charger. Now I have one. This charger would charge it in 1 hour. In fact, this charger has a 100 amp charging capacity, and it could charge a whole bunch of these batteries in 1 hour. But you don't need quite that much power, so that'll work for you, right?
Yeah.
The fact is, these batteries can handle a lot more input and output than these lead acid batteries. Maximum output, this battery can do 120 amps in 5 seconds, over 5 seconds, and the lead acid can do 180 amps in 5 seconds. So it sounds like it can do more. Your go-kart only uses 14 amps. So this can put out 30 amps continuously all day long with just one battery. So you'll never come anywhere close to overloading this battery. These batteries are also lighter. Yeah, this one's 27.6 pounds. This one's 31.1 pounds.
Wow.
Both heavy, but lighter means you can go faster, right? Are you enjoying this? You like learning new stuff? Mm-hmm. Okay. This is the charge-discharge curve, okay? So over here we have the voltage of the battery pack. And down here we have the percent of charge, so how much power is left in the battery. Now, you can see the lead-acid battery starts at about 56 volts. And then as you drive it, the voltage continues to fall until you get to 100%, and it's all the way down here at about 40 volts. Did you notice as you drive, you get less and less power? And that makes you sad, right? Because nobody wants less power. Well, these batteries are very different. It starts at a higher voltage, and as it runs, see how flat that is? Mm-hmm. It stays above 56 volts for the entire time you drive it. When you get to 80% capacity, where it starts to fall off, that's when it'll shut itself down, and it'll be time to recharge. And you'll have full power the whole time. In fact, at 80% life, your lead-acid batteries were only putting out about 46 volts, and this will still be putting out 56 volts. So the voltage is directly related to how much power you'll have. Higher voltage, more power. Any questions?
Nope.
Okay. Just self-explanatory, right? Okay. A little bit later, we're going to talk about solar charging, but before we do that, let's put this thing together and see how it works. You ready?
Yep.
All right, let's do it. All right, Judah, we are going to start hooking things up, but from a safety standpoint, This is 50 some volts, and you probably don't want to get shocked by that. Although it's considered low voltage, it might not be the most fun. So I've got some gloves here that will help insulate your hands, but we'll still treat everything as hot. So first, take off all your jewelry, take off your wedding ring. No wedding ring?
No.
Okay, well, I'll take mine off. All right, you can put those on. We'll start wiring stuff up. This is the speed controller, and it controls the power that goes to the motor. And it used to have a cord like this in it to connect your old battery. I swapped that out with an Anderson connector so that we can plug in our new circuit breaker, okay? Circuit breaker is mounted on this piece of plexiglass. The battery is strapped down to the go-kart, so we're just going to slide this under that strap. There we go. Now that's secure, and under normal circumstances we could connect the positive lead here and the negative lead here, and then when you want to charge it you would connect this to your charger, and when you want to drive you connect these together. And let's just make sure the breaker is off, so
We don't get zapped.
yeah, off is down, up is on. Now you can tell because it says that, but also because it's really easy to turn it off and it's a little bit harder to turn it on. So we'll put it in off position while we're wiring things up. We want to add this shunt so we can take some data while we're driving. To do that, we're going to put it in between the negative and the negative battery post. Okay?
Okay.
Now the first thing we're going to connect up is the positive wire, because when you connect the positive wire, if the negative's already connected, usually that's connected to the chassis. And if you came across this metal post and some part of the chassis, it might arc. Okay, so we're going to connect the positive post first. Unthread that screw there. Don't lose it. A little harder to do with gloves on, right?
Yeah, but safety first.
Yeah, that's good. Now, when we put it in, we want to make sure that it's not clamping this insulation, because that would prevent a good solid contact. And then one other thing, if these aren't tight, then you'll have resistance, and that can cause heat, and we don't want heat. So this is a torque screwdriver, and we can set the amount of torque we want to set this to. We're going to use 5 Newton meters for this. So all you have to do is tighten it down, and it'll beep at you when you get it tight enough, all right?
All right.
Give it a shot. You might need 2 hands. Takes a lot. There you go. Until you hear it beep, solid beep. There. Okay. You got it. Now we'll just slide this
Rubber
silicone
insulator
boot over the top of it. Now, it's pretty unlikely we'll touch this. We don't want to touch this to anything else. Okay, so we're good there now. Now we're going to put this shunt in, and this will measure power for us. So you can pull those 2 stickers off, and then we need it to be battery on this lead and power on this one. So we're going to stick this right about there, okay? There you go.
Okay.
Just stick it down. There you go. Okay, take that nut off. Now there's 2 washers there. One's the lock washer and one's a regular flat washer, and they both come off. Then slide them back on. Need a little bit smaller glove for you, don't we?
Yep.
We're going to pull this so that the insulation isn't under it. Okay, and then feed that nut on there.
Somebody.
Yep,
Why do I keep dropping things today?
That's where they go. They go on the floor. All right. Oh, you know what? There's one thing that we forgot, and that was we need this positive lead for this to give it power off the positive side. That goes in here. All right, before we connect the negative, we need to put the positive lead on the positive terminal. Muscle scope. There you go. Put our little boot back on. Now we have power to our shunt. Now we can hook up the negative terminal. Yep, slide that on, put all your washers on. Then take that one off, and we'll put the negative lead that goes to the go-kart on that end. Stack them back on there. Yep, you got it, the right order. Let's tighten it up. Okay, it's good. Do that one. Okay, now we'll do this one. All right, slide this little boot up. Eventually this will go on the battery terminal, but we can put it on here for now. Now we can connect this communication cable. There you go, plug that into there, and then plug this end into there.
There we go.
All right, look at that, powered up. So it's telling us right now that we're at 53.3 volts. Has a little light. So once this thing learns what the level of the battery is, then it will tell us in here, okay? We can route this up here so we know what's going on.
So I can snake it through like there.
Yeah, that's a good idea. Let's snake it through there.
That way the rest of the cable could just sit in there.
Yeah. Now for the moment, we don't have a mount for this, so we'll...
Double-sided sticky tape.
I think you got it. Double-sided sticky tape.
I was thinking we could pop the wire through that hole right here.
Yeah, I think you're right. We could do that. All right, peel that off, then center that over the hole and stick it like that. There you go.
It's a little bit crooked, but...
That's okay.
You want me to clip through this?
Here you go. Try that.
Okay.
Nice job. Now everything's wired up, breaker's off. You can connect the battery to the go-kart. Push hard until it clicks. There you go. Okay, now open that box. Okay, push the breaker up. Close the lid. All right, let's go up to the front and see if it turns on. Turn the key. Look at that, power. Let's try and drive it. Looks like your tire needs some air. Let's fix that, and then we'll give it a run, all right?
All right.
It's test time. Ready? These tires are pretty worn out, Judy. You put a lot of miles on this thing, didn't you? Seems like you have to air them up a lot. Well, Endark sent me this really cool inflator, and I thought this would be a good opportunity to try it out. This one you can just set on and inflate to the pressure that you need it to be all in one shot. Do you normally inflate your own tires? And you use like a little gauge to see what the pressure is?
Yeah, we have a digital meter.
So you put air in it, then you check with a meter, and then you do that back and forth?
Yeah.
You know what the pressure's supposed to be?
Nope.
Read the tire. What's it say? Well, it says 24. 24 PSI. Take the valve stem cap off.
How if I did lefty-loosey, not righty-tighty?
Yep. Okay. Now, you just push this button and put it on. There you go. Now, you push this button to inflate, and when you want to check the pressure, you just let go. Keep going. It's leaking out the side. Go more. There you go, starting to seal. Okay, what's it say? 9 point what?
2.
Okay, keep going. Keep going until it says 24. Let go. Would you go over?
Yeah.
Okay, well, fortunately, you can fix that with this button. Look at that. Cool tool or what?
Mm-hmm.
All right.
Perfect.
Press the button and pull it off. Put your cap back on. Should we check the other tires while we're at it?
Sure.
Pretty good. Is that easier than the way you do it at home?
Yeah. Much easier.
All right, let's go. This is just a little array I put together using panels from Bouger-V, and these are 180 watt panels and those are 200 watt panels, but there's a unique difference between them. You can see on the front side these solar cells, right? They collect the sunlight. Feel that. Feel how warm that is. Pretty hot, right? Okay, now look down here. There's solar on the back side of this one.
Yep.
Now you see over here, these end ones don't have that. What's cool about this, these are bifacial panels, meaning they can pick up sunlight from the front and the back, right? So if you look at this chart, see these two plots. This orange plot is these two outer panels. These panels in the middle are actually a little bit less surface area than these outer ones, but they produce more power. See the two curves?
Yeah.
The orange one is down here and the blue one is up here.
Yeah.
And over the period of the day, these produce 6.5% more power even though they're smaller. Because they can collect light. You see how this reflective surface back here?
Yeah.
It just helps reflect some light back to the backside, but even without it, just light around them, it picks some of that up on the backside. And that allows these to be even more powerful than regular solar panels.
Neat.
Pretty cool, huh?
Yeah.
So you've been driving around on solar power, and we charge this battery from these panels. Actually, just those two middle panels can charge this battery in a couple of hours.
Neat.
Yeah, that is pretty neat, isn't it? So you can drive on sun power. The way we do that is with the solar charge controller that we looked at earlier. I've set this up to charge this 12-volt battery, just for example, because we've already completely charged yours, but it'll work exactly the same way. All we have to do is connect this Anderson connector, just like on your go-kart. Okay, and it powers up, recognizes it's a 12-volt battery. Now your go-kart's 48-volt, but we can do 12 or 48 with this charger. So now it's on, the light's on, and all we have to do now is connect it to the solar power. Now I have a 20-amp breaker here so that I can control the flow of electricity from the solar panels. You want to connect this up, snap those two together. Okay, and then those two. All right, now flip the switch. Okay, let's see if it comes up. Come back here a little. Look at that. See, the light came on. Immediately it sees the solar panels are kicking in. Now we can click through here. We see that they're at 29 volts. And it's putting out 3.1 amps. Oh, the sun just went behind a cloud. Now you watch, this will change when the sun comes out.
But it'll still collect some of the sun's light that it is coming, right?
Yeah, it's charging right now. It's 4 amps. All right, on the app, you can see it's putting out 3.3 amps, which is 44 watts.
Wow.
And that's just the two middle panels that we're running right now. So
Okay.
It's cloudy. Even though we're in clouds, it's still charging. And in a minute when it comes back out, we'll see what it jumps up to. Okay, here it comes. Watch as the sun comes around, this will jump up. 60 watts. You feel the sun on your skin now?
Mm-hmm.
Go ahead, read it out.
76, 87, 113, 139, 163, 182, 194, 203, 191.
A little bit of cloud wisps back in.
Yep.
See it dropping off? Isn't that cool?
66.
It's just exact. Now when you're out in the sun and you feel the sun beating down, it's like, oh, that feels like a couple hundred watts. Oh, that feels like 50 watts.
Yep. It's climbing.
What's it up to now?
221.
Right now, we're putting out 18 amps, 300 watts. So right now, this is charging the battery faster than that wall charger.
Wow.
Yeah, so, I mean, with this solar charge controller, we can use sunlight to charge faster than the plug you plug into the wall. That's pretty neat.
Yeah.
What is it now?
356.
356 watts.
That is a lot of electricity.
A lot of power. It's still going up. Yep, the sun has come out from behind the clouds. Okay, so this is a watt meter, and it measures how much power the sun's putting out. See, if I tilt it like this, it's over 1,000 watts per meter squared, which is about what panels are measured at. Now, if I put it up here, I can measure it at the angle these panels are at. Here, jump up here. Okay, so 1,092 watts, and this is putting out 350 watts. So this is how much power we would get if the panels weren't hot. Like right now, they're real hot. So if they're in a lab and they had 1,000 watts of sun shining on them, and they were 3 feet by 3 feet by 3 feet, so it's a whole meter. These are much smaller than that. They would be putting out 1,000 watts. So this is just a way to measure how much sunlight intensity we have. So this is pretty typical for the middle of a day. And that output is pretty typical for hot solar panels. The hotter they get, the less power they can put out. So if we were to run some water on them and cool them down, we'd see the power jump up.
Very interesting.
Yeah. You see that array out there?
Yeah.
That one there is powering the whole house.
Wow.
The dryer, the washer machine, the well, the air conditioner.
The hot water heater?
Yep, hot water heater too.
Hmm.
So, pretty cool, huh? You can just get a couple of panels like this. You could charge your go-kart during the day and run it all day, just with sunshine.
It's neat.
That is cool, huh?
Yeah.
Let's go out to the array. You want to do that?
Sure.
All right, so this is just 8 panels right here,
Mm-hmm.
and it's about 3,200 watts of power that it can put out. And I use it as a roof for my firewood, so it has dual purpose, right?
Yeah.
Now, this is enough power to run like emergency circuits for if there's a power outage or something like that. I can run my well, the refrigerator, some emergency lights, modem, security, stuff like that with just these 8 panels. Now let's take a look at the main array where we power the whole house.
Are those panels hooked up to anything?
Yeah, this is just 4 panels I use for testing. I got a bunch of grass on them right now, but these 4 panels run a dehumidifier in my shop, and these are used panels. So they used to be in a really big array, producing a lot of power for for like a solar company or something like that. And over time, they just don't produce as much power because, as the sun shines on them, they degrade a little bit over time.
Yeah.
So they can make more money or produce more power in the same area by putting new, more powerful panels. So you can get them really cheap. So these were really inexpensive. But like these are much bigger than the ones we were just looking at, right?
Yeah.
But they produce less power because they're older technology. But they still produce something, so we keep them around.
You got more solar panels over there?
Yep, that's another test fixture. Now you see these ones sticking straight up out of the ground here.
Yeah.
This is an experiment I'm doing to see how much power I can get when the panels are just standing vertical. There's some advantages, like there's a hailstorm or something, it can't break them, right?
Yeah.
And you can get power in the morning when the sun rises in the east, so it's going to shine on them pretty well. And when it sets in the west, right? So then it shines on them. Now, right now, it's about the middle of the day, and you see its shadow is almost a straight line behind it.
Yep.
So almost no sun is hitting it. So there's a little time in the day when it doesn't produce very much power. So you get this very interesting dip in the middle of the day. But if you supplement that with panels that face south, that'll fill in the middle, and you can get this really big curve of power all day long. So I'm always running lots of different experiments. Now, these are bifacial too, meaning they pick up sun on the front and the back. That's the front of one, and this is the back of one. Pretty cool, huh?
Yeah.
Okay, so then this is the main array. Now this powers the whole house, and you can see we have 2 kinds of panels here also. The ones on top are bifacial, and that's why you see the solar panel or the silicone on the back side, and then the bottom ones are standard panels. They only have pick up sun on the front. Let's swing around and see what it looks like from the front. Now all that power comes into these boxes, and we combine all the panels in, and then this runs to the house to go into those inverters you saw. And there it is.
Does this get hot enough you can bake cookies on it in the summer?
I don't think it gets that hot, but it gets kind of hot. I mean, can't keep your hand on there very long. They're pretty hot.
Yeah.
But if I just put my hand over it like that, the power drops. Yep, drops the power. These ones are cut in half, so you can shade the bottom and the top will still produce power. But just putting your hand over that reduces the power that goes to the house. Now, in the middle of the day right now, we're probably producing, well, I could look it up. Should we see what we're producing?
Sure.
All right, let's see. Oh, the sun's dipping again, but that's okay. We'll get it pulled up and we'll see what it is here in a minute. The cloud came out. When the cloud came out, we were putting out about 4 kilowatts, 4,000 watts. And then when the sun came out from behind the cloud, we jumped up here to 17,000 watts, 17 kilowatts. So that's enough to produce power for my house and several of my neighbors. It's a lot of power.
Yeah.
All right, what do you think?
I think you got a lot of electricity coming from that.
I do have a lot of electricity. You like the idea of producing power from solar?
Mm-hmm.
It's pretty neat. We have sunshine. God gives everyone sunshine. We just have to make use of it.
Yeah.
All right, Judah, We powered it up. You got to ride it around. What'd you think?
Awesome.
Is it better?
Yes.
Well, hopefully it runs for a long time for you and you don't ever have to buy more batteries. What'd you think about the ability to power it with solar? Was that pretty cool?
Really neat.
It's pretty cool. The technology we have now, we can use sunlight to drive your go-kart and cars around these days. Well, hopefully you'll get the 10,000 likes you were looking for. That's a big ask, but we'll ask him again. Give Judah a thumbs up so that he can get his 10,000 likes. If you want to see more projects like this one, how to build solar systems for your house, how to build batteries, how to install solar systems, run off-grid systems, you can check out some of these other videos right here. Or you can go to my website, projectswithdave.com, where I have all kinds of resources for you. If there's any products that I have discounts or otherwise, I'll leave that in the description below. You want to say I'll see you next time?
And I'll see you next time.
Or how about this? How about you say thanks for watching and I'll say see you next time?
All right.
All right, ready, go for it.
Thanks for watching, and I'll see you next time.
You say thanks for watching. I'll say I'll see you next time. Ready? Okay. Look at the camera.
How about you just say it?
No, you can do it. Go for it.
Thanks for watching.
And I'll see you next time.